Hello, dear friend. This is Himmet. Now, after the lecture 10, now we are in a position to give a homework 10. Homework 10 is about the volume of solid of revolution. Actually, as you can see that we have 4 questions, but the second question has 2 parts, and so we have totally 5 problem for to you. Right. Now, if you look at first problem, the first problem is please find the volume of solid obtained by rotating the region bounded by the curve 2x minus x square and lines x is 1 and x is 2 and the x-axis about the y-axis. Okay, this is our x of rotation or x of revolution. As you can see that we cannot change x of rotation, and x is 1 and y is x is 1 and x is 2 and x-axis. Okay, now I think we can solve the first question by using shell method. Okay, as you know that the shell in the shell method we must have opposite situation, which is the x of rotation is the y-axis and the other things is depends on the variable y. This is the our case, and so Vy is 2 pi integral. As you can see that we have just one function, one curve, and integral absolute value of x times f of x dx, and we have the limit of integration as you can see that 1 to 2, and so we need the sign of the inside of the absolute value. If you look at the sign table, you can see that the inside of the absolute value is positive, and then please complete the other steps. Right. Now, the second problem is we have such a region. If this region is rotated about the x-axis or y-axis, then we will have the cone, and then this cone, the volume of this cone can be calculated by using the disk method. As you can see that our axis rotation is x-axis. First one is this one, and the second one y-axis. In terms of the y-axis, our volume is given by this formula. Right. The question 3 is please find the solid obtained by the rotating about the y-axis the region between the curve x square plus 1 and the line y is 3. If we look at this region, and then we have such a solid, and then if we use this method, then we will have such an integral. Y square is x square is y minus 1, and then our axis of rotation is y-axis, and so integration limit must be depends on the variable y. Y is 1 and y is 3. Integral at that time, integral from 1 to 3, and so please continue such a way. Right. All right. Now the problem 4. Find the volume of the solid generated by revolving the plane region bounded by the curve y, and the line y is 4, x is 0 about the y-axis. As you can see that we have, again, we cannot change the axis of rotation at this is our fixed situation, but we can change, I think, the other things, and so if we can, I think, use these two methods. First one is this method. If we use this method, we know that in this method everything is suitable with others, and then this is our axis of rotation is y-axis, and our limit of integration depends on the variable y. Y is 1 and y is 4, and then x square dy. Please continue the other step. The second method, the second way is shell method. In the shell method, we know that we must have opposite situation, which is axis of rotation depends on y, but all the other things must be dependent on the variable x. As you can see that in this case we have two functions. First one is f is 4, g is our this parabola, okay, and then integration limits depends on the variable x, which is the integration limits can be obtained from by using this equation, and then we have x is 3, right? Our lower limit of integral is 0, upper limit of integral is 3, and so if we calculate, if you look at inside of the absolute value, you can see that this is positive, and so absolute value is disappear, and then please continue to complete the volume of the solid, the other step. Okay, right. Thank you very much.